Alexis Miller. I'm an engagement specialist at Solar United Neighbors. For those who aren't familiar with us, we're a nonprofit organization that helps folks to go solar, join together, and fight for our energy rights. We're really excited to share with you this Children's Solar Hour. Dory will be asking questions and making it interactive throughout the presentation, so feel free to shout out your answers. She'll be giving you a pause to be able to answer those questions, so feel free to shout them out. Your dog will hear, your siblings, your mom. You can help teach the others that are around you, or if it's just you, for your learning. So feel free to participate in that way. If you have any questions, like I mentioned, please feel free to put them in the chat feature, and we'll be sure to answer them at the end. I'm going to turn it over to Dory to get started. Again, we're super excited to have you all here.
Thank you, Alexis. Good to be here. So I'm Miss Dory, and I just warn you, I am an energy fanatic. I love all things energy. I love creating energy. I love saving energy, and especially I love renewable energy. And so that's what we're going to focus on. I'm going to share my screen, and I'll bounce back and forth from sharing my screen to coming back. So bear with me. I'm going to share my screen, and we are going to begin the Children's Solar Hour. So glad to be here. And I'm going to start by asking you the question, what is energy? And so think about energy. When you have a lot of energy, like this woman looks like she has a lot of energy. What is energy? The scientific definition of energy is the ability to do work. Okay, so right now she's just jumping. That's her work of the moment. But my question for you is, where do you use energy in your lives? And so I've given a few little hints, and you know, because even just jumping for joy, even playing takes energy. You use energy when you play. Your parents and you probably help to do chores. It takes a lot of energy to cook meals, to do laundry, to even put the lights on in your home, and then to run your computers and to keep your house warm or cool in the summer. So there's energy in our lives, a lot of places. You can probably think of a couple others. So what forms of energy do we use? Like when you're playing or working or walking, you're using, I call it human energy. What's in you? What did you put in you to make you have all that energy? You probably ate some good food to give you energy. So that's the form of energy. Your human energy is powered by food. And then when you turn on a light, you use electricity. We'll find out what different ways that electricity can be made. How about when you're driving your car? Maybe some of you put gasoline in your car to power it. Maybe some of you have an electric car, and so it's run off batteries. How about when you're cooking? You have different types of cooking too. Some of you may have propane or natural gas, and some of you may use electric stoves. So we use all different forms of energy. And why do I care? Why should we care about the energy in our lives? Well, all the energy we use has an impact on our environment, on our earth. And so I just want to urge us to have the lowest, they call it carbon footprint, the lowest footprint we can on this planet, so we can do the best for the planet. And so as we think about the energy we use, I want you to think about where it might come from and what kind of impact that energy might have. So I'm going to start right up here in the upper left-hand corner with this cool factory store that's in New England that is powered by water. The water builds up behind this dam, flows over the water, and it goes through a turbine, and it makes electricity to power this factory. So that's hydropower. This pile of coal in the next picture came from underground, from dinosaurs millions and millions and millions of years ago, and we can burn that coal, create steam, and make electricity as well. In the next picture, the next two sets of pictures, we have this big pile of bark mulch, right, or chips from wood, from trees. And we put that chips into a furnace and burn it, and again, make electricity to power our homes. So that's called biofuel, from biomass, from trees and other plants. And then in this picture, that might be hidden, but if you can collapse that picture, we have a nuclear power plant that takes uranium and through chemical reaction makes electricity. And then below that, we have wind power that takes the wind and generates electricity from wind. And the bottom center picture, we're making electricity from oil or natural gas in a plant. And in the last picture in the lower left-hand corner, we have a solar farm, a large solar farm making electricity from the sun. So, question for you. Do you know what is sustainable? Nice big word there. What is sustainable? The definition is to be able to be maintained at a certain rate or level. So my question for you is, as an example, if you had a cloth napkin or a paper napkin, which would be more sustainable? Which would be able to be maintained at a certain rate or level over and over again? Paper napkins get kind of cruddy after one use, but cloth napkins can be washed and used again and again. So in that case, cloth napkins would be more sustainable. Okay, so what is renewable? That's another big word. You're going to learn lots of big words today. The definition of renewable is capable of being renewed. Okay, so I'm going to go back to that other slide that we just had, and I'm going to ask you, what types of energy do you think are more renewable? Okay, so up here in the hydropower, as long as the water cycle works and we keep getting water to flow down that river, then that hydropower, once built, can be considered renewable. Once we take the dinosaur coal and burn it up, there's no more coal, so that's considered not so renewable. The biofuel, if we're careful to plant the same number of trees and give them the same amount of time to grow as the trees we're harvesting, it can be considered sustainable and renewable. The nuclear is a challenge because you have to find the uranium, but it's also a challenge because we haven't yet figured out what to do with the waste. So it's not quite sustainable in that we can't yet process those wastes. The wind, it's nice, the wind keeps blowing, so that is a renewable resource. The oil and the natural gas is similar to the coal, that once we use it up, it's really gone from our ability. So that's not considered renewable. And as long as the sun shines, then solar power would be one of those renewable, sustainable energy sources. So you learned two big words, sustainable and renewable. I hope that helps you think about your energy. We're going to focus on electricity when we get to it, but first we need a break. We need to sing a song. So I love to sing, and I've written a couple songs I'm going to share with you. And this first one, called Think It Through, is just helping you think through some of these decisions you make in your lives concerning energy and care for the environment. But I'm going to stop sharing because I want to teach you the chorus, and it's got a little hand motion to go with it. So the chorus goes like this. I'll say a line, and then you guys say it after me again. Shout it right out. Think it through. What should we do? All right, try that. Think it through. What should we do? Good. And the second time we do it, the ending is slightly different. So listen carefully. Ready? Think it through. What should we do? Ah. So rather than clapping that second time, you're going to go, ah. Okay. So let's do the second phrase, the second time, second two. Ready? Think it through. What should we do? I think it through. What should we do? Ah. Beautiful. All right. We're going to now do this song, and I'm going to count on you to think it through nice and clap loudly and all that good stuff. Here we go. So there's lots of words. I'll do the words. You don't have to worry about the words, okay? Until we get to the chorus. I'm walking down the path through the nice green grass. My lawn is looking great, not a weed in the place. When what do I find but a dandelion? I think it through. What should we do? I think it through. What should we do? Ah. Do I let the flower mellow, turn my green grass yellow, make dandelion wine and a salad so fine? In the country, maybe. In the city, let's see. Rather than use chemicals to get rid of those yellow pals, I'll take some time to dig them up. Aerate the ground the worms can suck. Throw them with a smile in the compost pile. Think it through. What should we do? I think it through. What should we do? I've got to get to school. It's a golden rule. It's late. I'm feeling lazy. To walk there would be crazy. It's really not that far, but could we take the car? Think it through. What should we do? I think it through. What should we do? The car's a mean machine using gasoline. Instead, I'll use my head, and on my bike I'll take a hike. Now ride my bike to school. Now that is cool. Think it through. What should we do? I think it through. What should we do? I'm in the grocery store buying food. It's a chore. What to buy and how much? Made from scratch or from a box? Plastic wrapped or styrofoam? Oh, what should I bring home? Think it through. What should we do? I think it through. What should we do? If we could use less packages and make our food from scratch instead, we'd use less waste. In the end, less garbage helps the earth to mend. Reuse and recycle, or where we can. Think it through. What should we do? I think it through. What should we do? I'm walking through the house, and where'er I go, I turn on every light so it's all aglow. Turn up that heat too. Isn't that okay to do? Think it through. What should we do? I think it through. What should we do? Each light that's on takes energy like gas or electricity, so turn them off when not in use and save the earth from that abuse. Keep your heat on low, you'll be Earth's hero. Think it through. What should we do? I think it through. What should we do? See what we need to keep in mind. The Earth's our home for all time. She'll spin green if treated right and bring us joy both day and night. So make your choices carefully. In all you do, think it through. What should we do? I think it through. What should we do? Excellent. Good job, guys. All right. Well, that's one of my favorite. And I'll share another one later on. But first, we're going to do a little science here, okay? You ready for some science? How do we measure electricity? So that when you flick on a switch, you get some light, it's great. How do we measure that electricity? We measure it in a power of units called watts, okay? So what is a watt, you may ask? A watt, as I've said, is a measurement of power. Power is a very easy mathematical formula, volts times amps. But what are volts? I need to teach you that. Volts are like potential, the height of the dam. So you think back to the hydropower and you think, how tall is that dam? How much water is stored behind it? That's the potential, that's the voltage. How about amps? What's that? What's amperage? It's the current, it's the water over the dam. It's how much it's coming, how fast it's coming. That's your amperage, okay? So if you take volts, that potential, times amperage times that current, you get power behind that dam. Okay, but rather than water, let's make electrons move. So I'm going to show you this diagram. It's kind of small, but bear with me. I'm going to show it to you in real life. Here is a coil, okay? A coil of wire. And wire is, we're going to find out, has some electric charges in it that we're going to be able to make move. How are we going to make them move? By spinning, or in our case, we may shake a magnet, okay? So this magnet spins, the charges want to move, they go through, and they actually light a light in this example. All right, so we're going to do this science experiment. I'm going to stop sharing, and I'm going to show you that I have a coil of wire with two ends. Okay, so I'm going to make a circuit with that wire. I have a way of measuring electrons moving with my voltmeter. So I'm going to put it on the smallest setting, and I'm going to make a circuit by taking the wires from the voltmeter right here and connecting them to my coil. All right, so bear with me. I'm going to connect one to one and then another to another. And if you remember that diagram, so now I have the circuit all closed up and I have my voltmeter, which reads 0. That's good because there's no electricity moving. I want to make those electrons move in that coil. What did I need? Do you remember from the diagram? This is a magnet, but I have to prove to you it's a magnet, all right? So a magnet attracts metal. Oh, it's a magnet. I've proven to you because this is a piece of metal and it attaches, so very nice. Okay, so I've got my magnet, I've got my coil. I'm going to put, instead of turning this, because I can't turn it fast enough, I'm going to shake it back and forth, and I'm going to see if that magnet can make some electrons. You're going to see. You're going to look at that voltmeter and see if it changes. All right, are you ready? Here we go. It's doing it. I see that voltage changing back and forth. So we made electron move, but that doesn't really do much work, right? I had to do a lot of work to make that happen. So let's see if we can do some work with our electrons. And to do that, I'm going to get a little more sophisticated. Rather than that funky coil, I'm going to take this device, a handheld generator. And unfortunately, and so at the end, you've got a little light bulb. Just like that diagram, I'm going to try and make that light bulb glow. You have to trust me on this because you can't see it, but inside that metal there is a coil of copper wire, and there's a magnet that I can spin with my hand like that. And when I spin it, what do you think is going to happen? Because we learned if I have a coil and a magnet and I spin it, I will get light. Let's see. Ready? Did you see the light go? Here, do it. All right. So we just made this light bulb light up. What kind of power? What power was powering that? Do you remember? Was it human power? It was me. I powered that. I had to eat some good food to get that to work. So now I got a math question for you, okay? I'm going to go back to my screen, so hold on 1 minute. I'm going to share this screen and ask you a math question. So put your thinking caps on and let's go. All right, you already asked what source of power was making that light, and it was human power. It was me turning that crank. If that bulb is a quarter watt, like a quarter, 1/4 of a piece of pie, a quarter watt bulb, how many friends would I need to turn a generator to light up a 100-watt bulb? Okay, so that little bulb did very little light. I want a big, lots of light. So I want a 100-watt light bulb. How many of my friends turning a crank would I need to light up a 100-watt light bulb? Well, I'll let you think about that, but I want to break it down. For me, I like to go, all right, if I had a quarter-watt light bulb and I wanted to do a 1-watt, and I wanted to do a 1-watt bulb rather than a quarter-watt bulb, I would need how many friends? I would need 4 of those friends, each turning the quarter watt to get a 1. So if I have 4 friends with a 1-watt bulb, how many friends would I need for a 100-watt bulb? That's a little easier math. And there it is. I would need 100. I would multiply that 1-watt bulb times 100. So 4 friends times 100 is 400 friends. Wow, that's a lot of friends to turn to make that 100-watt light bulb. There might be a better way. Let's see if we can get the sun to do the work for us. So some more words, just so you know. Energy from the sun comes in particles or waves called photon, okay? And you'll recognize photon in this word photovoltaics, which is energy from the sun. So there's your volt, like voltaics is from voltage, and photon, photo. So photovoltaics, energy, electricity from the sun. How does that work? Well, a photon comes down, excites these electric charges like we just did when we had the magnet and the coil. They go through this layer, but they don't want to stay with their positive friends. They want to get back to their negative friends. So they have to go through and do some work, like light up a light bulb, or in our case, we're going to make a fan move, okay? Once they do some work, they release their energy, they can come back here just to get excited again. And that's called direct current. And that's how a solar panel works. But I don't expect you to just believe me. I need to show you, don't I? I need to prove to you that that's how a solar panel works. So again, I'm going to stop sharing. And I am going to present to you a small version of what is on my roof. This home is powered by solar, but it's much bigger array. This is just a little sample solar panel. So I've got a solar panel. It's got wires on the back. And I'm going to make a circuit with that panel. So I'm going to try, so I can show you that this solar panel can make a fan move. All right, so I need a fan. Let me bring a fan in here. Here's my nifty difty little fan. And it can move if you give it some energy. And it too has a wire behind it. And so I'm going to hook up this solar panel to this fan. And can you see that? All right, here we go. So again, I hook up the 2 ends, and do you think that fan's going to start moving right away? All right. Oh, it didn't. What are we missing from this equation? If it's a solar panel, we need what? We need the sun. Well, I'm inside now, so I brought the sun in with me. So poof, I've got the sun. So now, if I take the solar panel up close to the sun, will I get this fan to move? Let's see. I sometimes have to give it a kickstart. There you go. Can you see that? It's moving now. So I take the panel away, and the fan stops. I put the panel back underneath the sun and help it a little bit. There you go. And it starts again. So I have, from electricity from the sun, done work. I've made electrons move, and I've made power. So that's pretty cool. I'm going to go back to sharing my screen because I have questions for you, some more questions for you. And they are, hold on a minute. Oh, too many. Okay. Where do you live? I heard that you guys came from Massachusetts and Ohio and Texas and all across this beautiful country of ours. And do you know, we have good solar in our country. So here I am down in Texas, and I saw someone from, is here from Conroe. That's great. We have good sun here. You can tell the best is red. So if you're calling in from New Mexico or Arizona, you've got really good sun. That's the best. We've got really pretty good sun here. And look, even in New England and Boston and Vermont and New Hampshire, good sun. We are very, very fortunate. And I'll tell you that there's a way for you to find out exactly in your state, not only the sun, but how many homes are being powered by the sun. And how, like we have almost 500,000 homes in, we have almost 500,000 homes in Texas powered by the sun. Lots of solar jobs and lots of solar companies. And if you go to a website, sia.org, you can look on their state's maps and you can click on your map. Overall, we have 2.37 million installations throughout the country, okay? And planning a whole lot more. So have you looked around your neighborhood? Maybe you've seen solar panels on other people's homes. Sometimes, like in our home, they're in the backyard, so you can't see them from the street. But do take a look next time you're around to see how many solar panels you can spot. And then what about seeing them in these sites? Have you ever noticed a solar panel powering, say, streetlights, or powering a speed limit sign, or even powering some outdoor gardening? These solar panels are not connected to the utility grid. So when the nighttime comes, what happens? Do these traffic lights just stop working? That would not be very safe. In this case, we need something more to keep those lights on at night. So that's my question for you is, the sun goes down at night. How do we keep that fan spinning? Or how do we keep those traffic lights working when the sun is not out? And as you're thinking about that answer, I'm gonna suggest a solution. So the sun is going away. We don't have the sun to work with. And yet we want to power this fan. Have you thought about this idea? What do you think these are? Little batteries. Do you think they have energy stored within them? Let's find out. We're going to use our trusty voltmeter again. We're going to put it at a higher setting because there might be quite a bit of energy in these batteries. And we're going to see if we can find if there's energy. So again, I have a circuit for the batteries, and I'm going to connect it to the circuit for the voltmeter. And I do black to black and red to red. And can you see that? We have voltage, 3.5 volts. So this battery bank here has energy stored in it, just like that water dam, okay? So we're going to go ahead then and see if we can't make this fan move with battery power. So let me take the voltmeter, I'll shut it down, and let me bring this fan back up here, carefully. And I still have the battery bank, and you see, I should put that up so you can see it. Let's see if I can hook these up and make a circuit. And I don't think I'll have to work too hard, because that's a lot of energy we have there stored. So let's see if I can just touch this and see if we can get the fan to go. Oh, did you see that? I just touch it and the fan goes. So there's energy. We can have that fan at night. And if we put a battery with those traffic lights, we can have traffic lights at night. So that's a good solution. But you know what? Like I told you, this house has solar panels. We don't have we don't have to have batteries because we're connected to the grid. So the utility grid provides us power at night. We provide power during the day. All right, let me go back to sharing again, because I think we're getting close to our next song. Nope, math question first. Okay, we needed a lot of friends. You remember how many friends? 400 friends to take this little light bulb and make it to turn a 100-watt light bulb, the equivalent of 400 of those bulbs. So rather than 400 friends, if we took one of these solar panels, and this solar panel could do 4 of those bulbs, right? How many little panels would we need to light up a 100-watt light bulb? So there's the math question for you. Let me say it again. If one solar panel can light 4 bulbs at a 1/4 watt each, how many panels would be needed to light a 100-watt bulb? You can shout out your answers. I'll give you the answer right now, okay? All right, we had a 1/4 watt bulb and 4 bulbs to a solar panel, so a 1 watt, each panel can do 1 watt of bulbs, but I need 100 watts. So how many solar panels? I need 100 solar panels. Luckily, those are tiny little panels and we don't usually use 100-watt bulbs because I only have 9, I have 30 900-watt panels. Did I say that right? No, I didn't say that right. Hold on. We have panels. Hold on. So I have a song now for you. Let me just say that again. We have a 9-kilowatt array, 9,000-watt array. It's 30 panels at 300 watts each. That's the math for my house. All right, but now there's a song, and it's called What's a Watt? And this chorus, what's a watt? It's what I've got, growing in the open air, out on a pole or on the roof, raising them without a care. They're incredible, hardly edible. Watts don't do any harm. What's a watt? It's what I've got, growing out on the farm. So I want to teach you some hand motion for this. So I'm going to stop sharing and teach you the hand motion, and then we'll go through and sing that song. Here we go. So I'll sing a line, you guys sing it after me. What's a watt? It's what I've got. So try that. What's a watt? It's what I've got. Growing in the open air, growing in the open air. And then out on a pole, you're going to put your hands straight up in the air like you're a pole holding a solar panel. Out on a pole or on the roof. Like make a roof with your hands, good. And then raising them without a care. And then this part, if you're standing, you could dance a little bit to one side and dance back, but they're incredible, hardly edible. Try that. They're incredible, hardly edible. Watts don't do any harm. Try that. Watts don't do any harm. And then you repeat the first sentence. What's a watt? It's a what I've got, growing out on the farm. Try that. What's a watt? It's a what I've got, growing out on the farm. Good. Okay, I'm going to share my screen and you can sing along with the choruses. I'll do the verses so you don't have to worry about those. But we'll start with the chorus again from the top. Are you ready? What's a watt? It's what I've got, growing in the open air, out on a pole or on the roof, raising them without a care. They're incredible, hardly edible. Watts don't do any harm. What's a watt? It's a what I've got, growing out on the farm. Started out small, just a panel, that's all. Added some more when we could. They don't need water in no messy stalls. They don't need any food at all. We watch our watts and how we use them. Conserving certainly helps. They don't pollute the environment. Energy that's heaven sent. What's a watt? It's what I've got, growing in the open air, out on a pole or on the roof, raising them without a care. They're incredible, hardly edible. Watts don't do any harm. What's a watt? It's a what I've got, growing out on the farm. What can you do with a bunch of these watts? You might be curious to know. Light up the night, keep computers bright. They can actually run the whole show. What do you need to raise a watt? Sunshine certainly helps. No matter where you live or work, you can be an energy farmer too. What's a watt? It's what I've got growing in the open air. Out on a pole or on the roof, raising them without a care. They're incredible, hardly edible. Watts don't do any harm. What's a watt? It's a what I've got growing out on the farm. Good job, good job. That's just a fun song. All right, now I've got a little challenge for you, a little homework for you. How can we use less energy? How can we make our carbon footprint smaller on this planet? How can we choose our sustainable process? Yes, but how can we use less energy? And there was a line in that song that says, conserving certainly helps. And conserving, using less energy, certainly does help make powering by the sun more fun. So I'll ask you, with your parent, don't do this on your own, but see if you can find your electric meter on the back of your house, somewhere outside usually. See if you can find your meter and study it for a while. Yours may not look like this one because ours has solar, yours may not. In a normal house, there may be an indication to show you're using energy and it's going in one direction. On a solar home, on a sunny day, I can actually see it move in the opposite direction. It's kind of cool. I'm sending energy back into the grid. And so my challenge for you is, can you make it go slowly? Can you make the meter slow down? And how might you do that? So if you're walking through the house and where you go, you see all the lights aglow, turn off some lights, right? How about there's, if you don't open your refrigerator a whole lot, if you don't stand there with the door open all the time, that would be good. Sometimes if you don't keep your computers, if you have a phantom load, a black box that's keeping your TVs warm and everything ready to go on an instant, if you shut those down, that takes less energy too. So think about how you can make your meter slow down. And then of course,
yes. We had someone also suggest to use less electronics to save energy.
There you go. Go outside and play. Don't play on your computers. That's a great suggestion. Good, good. I love that. So see how slow you can make your meter go. And then, of course, I warn you, it's just fun to put solar on and then see it go backwards. That's very fun. Another way to have fun is you can actually earn a patch from Solar United Neighbors, which is a pretty cool thing. So they have a whole curriculum, things you can do from your home to learn more, even more about solar and to become, an energy advocate and an ambassador for solar. So that you can find on our website, and we love to have kids participate that way. So I think that is it, but we're open for questions and other good comments, and we just let you know that on solarunitedneighbors.org you can find a whole lot of information, and we do co-ops to help people go solar. We have great help desks. So Alexa, what else should we tell them?
Yeah, if anyone has any questions, feel free to put them in the chat box and Dory or I can answer. But yeah, that's everything that we have to share with you all. We hope that you're able to learn a little bit more about solar. And as Dory mentioned, as a nonprofit, Solar United Neighbors does help people to go solar through co-ops and our membership program. So if your family's interested, they're welcome to check out our website at solarunitedneighbors.org, and we'll also send your parents an email with the patch program that Dory mentioned and some other ideas for you to learn more about solar while you're at home. And we encourage you to continue to look for ways that you can save energy, as well as look for solar panels that you can find in your community. You'd be surprised how often you find them. I know that someone mentioned they have the little solar panels in their front yard, so that's great. And some of your neighbors might have those, or different locations around where you live. So we encourage you to continue learning more about solar, and we thank you all for attending. Thank you so much, Dory, and have a great day, everyone. Looks like we don't have any questions, so we're good to go.
Thank you, Alexis. Take care, everyone.
Thanks, guys.